flood risk forecasting, and I'm utilizing data from the National Water Model. And as you can see here, the National Water Model predicts stream flow across the nation, and that forecast can be short range, medium range, or long range. And I'm looking at medium range, which is a 10-day forecast. And their output is predictions of stream flow at millions of locations, and in addition, they also output depth of ponding. So to visualize that, I'll move over to GIS, and we're looking at New Orleans here, and the National Water Model says that New Orleans in 10 days has a risk of having 122 millimeters of ponding right here next to the lake. And these cells are 250 by 250, so it's pretty approximate. So what I propose to do with this is to calculate statistics for each of these given areas. So for New Orleans, we would calculate average depth of ponding, and I have done that and created a spreadsheet. So 10 days into the future, we'd expect that the city Violet will have a mean depth of ponding at 116 millimeters. And then for that given location, if we track this over the course of multiple weeks or months, we could say that the threshold for this given city is an average of 200 millimeters. And if that threshold is passed, I propose that we notify the city of imminent flooding through an email. And in that email, we'd say the National Water Model predicts, etc., and we would provide them with ponding depth KML, which is essentially a flood visualization resource. So what I have done up until this point is to develop a model builder, which is supported by Python, and it takes we'll look at this. It takes the National Water Model netcdf file format, converts that to a TIFF. You specify your location of interest, what you want your KML to be called, what type of symbology you'd like it to have, and where you'd like your zonal statistics run on. And in the end, we are left with this KML, which is quite useful. So we'll open up Google Earth here, and then we'll import that KML for the whole US. And again, this is 10 days into the future. What do we expect the flooding to be, or the ponding depth? And we'll change that altitude to relate to the ground. Say we're looking at Miami. What you see here are 250 by 250 meter cells that are accurately referenced to the ground. So at this factory, right over here, we have 0.165 meters of flooding. And then in this channel, 0.164. Let's see if we could find something interesting. This looks like a maintenance garage, and right on the outside it's 0.15 meters of ponding depth. 0.16 over here. So going back to the post, we would provide the flood visualization resource, which is the KML, and this would help city planners to go out and knock on people's doors or potentially sandbag different locations to prevent flooding from occurring 10 days in the future.